Effect of temperature on state. We've previously learned that energy is a property of a system. It is conserved, which means that the total energy of a system is constant unless energy is added from outside. There are two ways to add energy to a system: work done by an external force, heat flow into or out of the system. In this unit, we will be examining the effect of heat flow. As heat is added to a substance, either its temperature increases or it changes phase. It takes a lot of heat to melt ice or boil water. All that heat goes into the phase change. The temperature stays constant. Either do the experiment in this video with proper supervision and safety procedures, or watch this video with the sound off and discuss what you observe. As a solid heats up, energy is stored in its particles as kinetic energy, the energy of mass in motion. The particles vibrate more around their fixed positions, pushing against each other. The distance between particles increases, so the solid expands. Bridges are solids. Shown here is an expansion joint on a bridge. Why do bridges need expansion joints? Discuss. At a specific temperature, called the melting point, the attractive forces between the particles of solids start to break down. The solid begins to change into a liquid, a process called melting. While melting, the material's temperature does not increase, since the thermal energy goes into breaking the forces of attraction, not kinetic energy. The change in state from solid to liquid is called melting. Melting happens at a specific temperature called the melting point. The melting point for water ice is 0 degrees Celsius. That is the temperature at which ice and water coexist. A lot of energy has to be added to ice to melt it into water. While melting, the temperature of the ice-water mixture stays at 0 degrees Celsius. Some thermometers are made by filling a glass tube with a liquid. Warm one of these in your hands and see what happens. What happens to the liquid? How could you calibrate an unmarked tube to measure temperatures using the Celsius or Fahrenheit scales? Discuss. Hint. Consider what we learned about the temperatures at which water boils or freezes. Normally, as a liquid gains thermal energy, that energy is stored in its particles as kinetic energy, the energy of mass in motion. In this case, the particles don't have fixed positions, but as they move more, they still push against one another. Since temperature is related to the kinetic energy of the particles, the temperature of the liquid goes up. Also, the distance between particles increases, so the liquid expands. When the particles in a liquid gain enough energy from heating, they break free from each other and form a gas. High-energy particles escape the liquid as gas. It happens faster as the liquid is heated. At a specific temperature called the boiling point, evaporation occurs throughout the liquid, not just at the surface. Evaporation is the change of state from liquid to gas. While boiling, the temperature does not change, since the thermal energy goes into particles breaking free of their attraction to other particles, not kinetic energy. The boiling point of water is 100 degrees Celsius. It takes a very large amount of heat to boil water, much more than to melt ice. The boiling process turns the liquid into a gas. In the case of water, the gas is called steam. Adding energy to a gas increases the kinetic energy of its particles. They move faster. Here's an illustration of gas particles in motion. Particles in a gas have the highest kinetic energy of all the states of matter. The opposite of evaporation is condensation. When a gas condenses, it turns back into a liquid. Condensation occurs when particles of a gas lose energy. They come closer together to form a liquid. For instance, when dew forms from the cooling of water vapor in the air on a cool morning. Or when water vapor comes in contact with a cool water bottle and the gas particles condense into liquid water. The opposite of melting is freezing. The freezing and melting points for any substance are the same. For example, the freezing and melting point for water is 0 degrees Celsius. When you put liquid water in the freezer, the particles of water lose energy. The force of attraction between the particles increases, causing the particles to come closer together, forming a solid state. That is how this ice cube was formed. All these processes are reversible. So let's see what happens as we remove heat from water, moving from right to left.